Hello everyone, my name is Sławek. I'm a student of fastai course from year 2020 and I'm just after lesson 1. I'm trying to learn better how to explore and debug fastai code, and after some fiddling with it, I wanted to show you 5 different ways I came up with to understand better what's happening inside fastai. Those are by no means the best ways or recommended ways, but just something I found out that works for myself, and maybe they will be useful for you as well. First of all, we'll talk a bit about my setup. I'm using Paperspace for the GPU server and the Gradient notebook, and I'm also running a local Windows PC where I have Ubuntu shell installed, and I have Visual Studio Code locally on my PC as well. So let's get to it. I was just looking through the lesson 1 of the course, and as part of the homework I decided to understand better what's happening in some of the codes here, and I was looking at the segmentation example. So I've done some image recognition before in PyTorch and in fastai, but I've never done segmentation, so I wanted to understand better what are the inputs, what are the outputs, how the images we see here are generated. So let's get right to it. So first of all, if I want to understand how the input works, I can just directly look at the images that were downloaded. I can call the getImage files function to see what the files are that got downloaded from my dataset. So these are the paths. Now I can just take a look at one of them. I see there are PNG files, so it's safe to assume those are images. So I'll just do image open one of them. So as expected, this is just an image of a street. Now I can also look at the labels, which might be more interesting. So I want to list the labels. That's also a PNG file, so I'll try to open it here. This is quite dark, but there is something here that also resembles a street. I can look closer what's inside this PNG file. So I can make a array out of it. The pill image class has a getData function. No, getData. Okay, so this looks like some array of integers. This sample here is pretty small. Let's see, the minimal value is 4, and okay, so between 4 and 30 for this particular label file. And if I look back here, there's also codes.txt file, so let's just take a look at that. Okay, so this looks like names of the classes, and how many of them do we have? 32. Okay, so it's pretty clear that the classes here corresponds to the numbers in my label image. So I have just, for each pixel, I have one of those classes as a mask. So now the next thing I wanted to understand is how these images here are generated, because this looks not like the mask I just opened before, but it looks like something superpositioned on top of the image and has different colors, and I don't know which colors correspond to which classes, so I wanted to find that out. So let's start with looking at this function. So if I do double question mark in Jupyter Notebook, it will show me some function signature here. So I can see that it takes something from the data set, I guess, and then calls show results function on another object. At this point I'm still not sure what that is, but I can also see the source file that this code is in. So the first way, just look at this file directly, so I can just vi and open this and search for show results. Okay, so this is the same code we've seen before, and now what I can do is just put a print statement here. And now in my notebook, at the very beginning, I have this command to auto-reload the code that it uses. So if I run this again, okay, I get my hello message and some warning. So now that I know that this is the function that is called, I could debug it further. For example, I'm curious what the self.dls is. I can print out the type of it, for example. And now if I run it again, okay, I know it's fastai 2 data core data loaders. Now this is a very crude method, but if I continue printing out stuff, eventually I will figure out what's happening there. This is the most basic form of debugging, just print statements, and you might think that it's not very powerful, but in reality this is often the most available method for debugging. Like, you're working on large systems, like you are not always able to connect your visual debugger, but there are almost always some log files or some console outputs that you can do. So print debugging, the most basic thing. You might also have noticed that I'm doing something horrible here, like I'm editing directly the file that was installed from Anaconda. You should not do it. You can also install fastai from a local checkout, and that's much more friendly way of doing it, but this works. It's quick and dirty, but works fine. So now you can add whatever print statements you want, as long as you remember to remove them later. Like, there's no harm in doing that. Okay, but let's try something different. So the next thing I will try is using the PDB debugger. That's part of Python, like standard debugger that you will always have available. In Jupyter there is a debug command. I can do %debug and then just call the method as before. So this opens an interactive debugger that is pretty simple. It just uses some keyboard commands to operate. L is for list to show more of the code, and then I can move to the next line, and you can see that it shows me which line I'm at by this little arrow here. So I can continue. If you type help, it will show you what the commands are, but you can also find a cheat sheet online for that. But just using L, S, N, you'll get most of the things done. Okay, so I want to continue moving here until I get to this line showing results. And you can also use this to evaluate. So before I use the print statement to find out what self DLS is, but in debugger here I can just type and I'm getting the same thing. And now I want to look inside this function, so I want to step in, and now it moved me to fastcore foundation file. Looks like there is something else happening here before the show result is called. So let's see. It's trying to read some attributes. Where are we? Here. As you see, this is not the most user-friendly, but this works. Want to see what's attribute? There is no such thing. Oh, wait. Let's move one more line. No. Okay. So this is some tfoundl object, the same we used from, and K is show results. So this piece of code just looks for the function to invoke at this object. So let's continue. Okay, so we are back in the show results, and now let's see here. Okay, so this is a different implementation of show results, like the function is the same name but in a different class. So this time we are inside tfoundl object, and we came from learner. So you can continue this way. You can inspect variables. You can go up and down on your call stack using U. Okay, so this is the place we came from, and then D to get back. So this way you can do your debugging. You finish with exit, and so that would be the second way. PDB also lets you set up breakpoints. There is a set trace command you can just insert in your code wherever you want to break. You could use the same trick I did before with the print statement to just put a breakpoint inside fastai code, or put breakpoints somewhere in your code and then go down from there. So now the next thing I will show is very similar, but it's using something called pixie dust, which is a debugger that it's kind of built on top of PDB. To use it, you have to first install pixie dust. I already have it, so I won't be running it, but you can just do it from your notebook directly, and then you can do import. Okay, so this imports it into your notebook, and now there's a magic command, pixie debugger. Okay, and now I do again learn show results. Okay, so this is a simple debugger inside Jupyter Notebook. It allows me to do pretty much the same thing, like step into function and see the code and go one line at a time. I can inspect variables again, so I can write whatever Python code here and it will evaluate it and show it. For me, it shows some local variables here on the left, so for quicker access. I can, for example, I want to see what B is, so I just, no, not defined, wait, that's on the next line. Okay, and now I have B. Just see a bunch of tensor images and tensor mask objects. And this way, again, you can debug as far as you want to understand what exactly happens in the code. I've just installed it yesterday. It's been a bit junky. I had some glitches, but it works. It does, it's very simple. I haven't figured out any keyboard shortcuts or better way to display the variables, but it might be a bit more user-friendly than just straight up PDB. Okay, so that was the third way. Now the fourth. So if you watch the lesson 1 of the fastai course, you might have noticed that Jeremy says that the whole fastai library was developed inside Jupyter Notebook, and we have access to those notebooks, right? Not only to the Python code I showed you here, but also the notebook itself that were actually used to generate the Python code. So let's say I want to learn more about this segmentation data loaders, which seems is responsible for processing and displaying this data. So I can call the doc function on it, which brings me to the documentation here, and also the show in docs link, which I will click. So this shows me segmentation data loaders on the dev fastai website. There's not that much here for this particular class, but what's important, if I look at the URL here at the top, it shows me this comes from vision.data, and now if I have the fastai repository checked out, which I do, there are notebooks here, and there is a vision data notebook. So I can just open it, and if I search for segmentation data loaders, it is here. This is the class definition we've seen in the docs as well. And the cool thing is this is fully runnable, including examples. So I can just run all cells. It will take a moment. I hope it's not downloading any datasets anymore. Okay, so this worked, and this worked as well. And now I have some instance of the segmentation data loaders, and I've seen there's a show batch function there, which is slightly simpler than show results because I don't need the model outputs. I'll just show the input data and the labels. Okay, so I get very similar output, but now this is generated based on the code in this notebook. So, which means I can not only look at all the things here, but I can also modify it and see the results right here. Okay, so let's see where the show batch function is defined. Okay, so it's in the same notebook. So now I see two versions. One takes tensor image and some unspecified y, and this one takes two tensor images. I remember mine had masks, not images, so I'm guessing this is the function that will be called, and I can actually validate it. And you know, I'm still inside the same notebook, so I have access to all the variables here, so I can just directly run show batch. Okay, I can see this is the correct function because I get it's me. So we're all good. So let's look further what's happening here. So it calls getGrid function. This has something to do with matplotlib. So let's continue. There's a show batch index with object. So I'm not sure what that is, but it's very easy to check because I can just run it in a cell, and it will show me exactly what it is. It's a function show batch that is located in data core package. So that's a different notebook than the one I'm in, but that's not a problem because we have access to that as well. So I'll look in the data core. Yes. Okay, and I have the show batch function. So now I will do something slightly hacky because the notebooks are not connected with each other, right? I cannot change the code here and see the output change there. I would have to generate Python files out of it and then load it in the other notebook. But there is something that I can do quick and dirty. Just copy the whole method here. I run the cell, and now if I run it again, okay, now I'm calling this local method of this function. So now I can do more stuff with it. So I see this takes some samples and then it iterates over them. I wonder what's inside the samples. Now I could try to read and code and understand it, or step in with debugger and try to understand what gets written to the samples variable. But I will do something much dirtier. I'll just create some global variable here, and I will do just write samples to it. So now after I call this method again, yay, I have the globals method, and I can inspected inside Jupyter Notebook. So you can see that this can be very useful because it's much easier to inspect data inside Jupyter than in a debugger or print statements in your Python files, especially when you're dealing with images, because I see there are some tensor image objects here that are showable, so just need to figure out the nesting here. Is that the tensor image? Yes. Okay, so I can inspect the variable, but not only see the data in it, but I actually see the image. So that's clearly something that a normal debugger wouldn't allow me to do. And I can look at the other index, and as expected, this is the label, but it looks different than what the plain PNG file looked when I opened it before. So there's something more going on here that I will try to understand next. But yeah, that was another way to explore the fastai code, just looking directly into notebooks, running the examples, and when examples are not enough, just create your own, add your own cells, and then modify the code or look inside the code. So the final thing I want to show you is actually using my local machine. So I have Visual Studio Code installed here. And I have a checkout of the fastai library here. So the things we were looking at previously were on my Paperspace gradient machine. Now I'm looking at my local Windows PC. To get this code in here, I just checked out the fastai from GitHub, and then I created a conda environment. So if you look here, so this is my fastai checkout, and it has environment YAML file that is a configuration you can use for conda environments. So I created an environment out of it. Okay, so I have my fastai 2 environment with all the dependencies needed for fastai. And now if we look back into the Visual Studio, back to Visual Studio, yes, you can probably, let's see, here at the bottom, you can see that it uses the same fastai 2 conda environment as an interpreter for the code I have here. Okay, so this is great for viewing the code. It's like more colorful and more friendly than using Jupyter or using Vim on the remote. It allows me to search for symbols easily. So we're in show badge method from data core. So I can just open this here, and now what I would really like is also debug from here, which turns out you can. So I want to put a breakpoint here, and now I have a tiny Python file that just imports fastai, and then creates an instance of segmentation data loaders. It's exactly the same as in the notebook, and then calls show batch method on it. And I can press F5 and debug it as Python file, and hopefully it will stop here. So this is the same place we've seen before in the notebook. If we look closely, it seems to be showing image twice in the same matplotlib axis. So this I variable is 0 now, but I can step over 10. Okay, and now I want to see what this function is doing, because now we'll be showing the mask, and I wanted to see where the pretty colors come from. So I want to step inside this. So I press F11. Okay, so now I'm inside tensor mask show method. It went in it. Okay. I have codes. Now you see here I have local variables on the left, so I can see that the codes. This looks like the same array we've seen before, or maybe we haven't seen, but it's the same array that the Jupyter notebook loads to show different classes of labels that we have on the images. Wait, I can show you that if we go back here, back to our notebooks. When we create the segmentation data loaders, we load from codes.txt file. And if I run this code here, okay, so this is just plain text file with all the different classes. And I'm guessing the indices here in this array corresponds to the values in the map image we've seen. Okay, so now I go back to my debugger. So I want to see what show does, okay? Because that's the part I still don't understand. I want to step inside it. Okay, so this is called show image. Let's go in there. Okay. So it sets some attributes. I can continue going. But in the end it calls ax image show. So that's matplotlib method, right? So now, why is it displayed differently than I've seen before? Well, there are some arguments we pass here. If I look at this variable, this quarks, I can see it sets alpha, transparency, it says color map, something called vmax, vmin. So that's probably the reason that the images look differently when I look at the output in my Jupyter notebook. So the last thing I want to show you, I wanted to validate that I understand exactly what's happening here. So I created a small notebook. This time I'm not using any fastai code, just some standard imports. I taking the same data set, and I just take a random file out of it. So this is the path to a random input file and the corresponding mask. So this looks like before, the image of a street. I don't know if you're able to see it, but this is the mask that here, just in different shades of gray, 32 shades of gray to be exact. And now I'm looking at I'm just passing the same parameters to image show as I've seen in the Visual Studio, and now I get something that looks much more closer to the output we're getting in fastai. So now I want to see if I can just render one on top of the other, and voila, this looks exactly as the thing we've seen. So I'm confident now that I understand how this printing of images works. Now I wanted to do one more thing, so I'm looking at the codes, and I wanted to see if I can just highlight the cars. So I took, what's the index of the car, and then I took the car data is my map, like labels image, but converted to numpy array, and I zeroed out everything that is not a car. There's some wonkiness happening here, that the size of the pill image is columns by rows, I think, and the numpy array is rows by columns, so I just needed to swap it so it shows correctly. And now I show there's a input image underneath, and on top there's a mask that only highlights the cars. So this part works, and if I use something else like bus, I can just substitute it here. Okay, now I only have buses highlighted. So I'm confident that this part of the code I understand. So that's pretty much all I had to show you, like 5 different ways to explore the code, just plain print statements, PDB, Pixie Dust debugger, Visual Studio Code debugger, and then just abusing Jupyter Notebook and the fastai code inside notebooks. One note at the end, you might have noticed that I have a lot of different versions of the same code I'm looking at, because I have the fastai checkout locally on my PC, I have fastai checkout on Paperspace, I have the docs that are on dev fastai, and then I have Python files from fastai installed from Conda, and I sometimes look at the GitHub source. So this can all show the same code if you're good about pulling, and the docs are up to date, but not necessarily so. So like you have to be careful when you juggle different instances, because if the code is different, then you might find yourself in a pickle. This is also, for this and other reasons, not optimal setup. It's just something I done quickly with the things I had. I already had Windows machine with Visual Code insert and the Ubuntu shell installed on it, and then I took Paperspace gradient because it was very fast to get the GPU instance of fastai running. So all this is done for convenience rather than robustness. Probably having a Linux machine with your own GPU would allow you to have only one place for all the code, and you just read it from one source of truth. but there is, you know, more setup and time and money involved to get that running. So for now, with what I have, this works pretty well. Uh, Let me know if you have better ways of doing things than I do, but I hope